Hello and welcome to a demo video of Ceph client running natively on Tachyum Linux. Before we get to the actual demo, let's have a few words about Ceph. Ceph is an open source software-defined storage system designed to address the block, file and object storage needs of modern compute systems. Ceph is here for some time already. Its first stable release was about 10 years ago. Since then, it has practically become a golden standard in many different use cases, ranging from small companies up to big data systems, and from cloud infrastructure up to supercomputers. Even CERN stores its many petabytes of data in Ceph. Main features of Ceph are scalability, performance, and high availability. It can run on one machine or even on thousands of machines with tens of thousands of clients that are connected to this storage. Ceph capacity and performance can be increased without interrupting the service simply by adding new nodes to the cluster. This comprehensive data storage solution provides completely distributed operations, all hosted locally on premises, without a single point of failure, when properly deployed. Here you can see the Ceph architecture. The blue boxes on the bottom are storage nodes that carry actual data. On the bottom left, there are so-called monitors that have the knowledge about which data reside on which physical nodes, and they are providing this information to the clients. You have the flexibility to choose how to present the storage to the client machines. There are multiple ways how to do that. The basic three strategies of presenting data, as you can see in the middle, are file system, block storage, and object storage. The Ceph file system is a shared file system, which means multiple clients can work on the same file system at once. The same is true also for NFS and CIFS file systems. Ceph block storage, or RBD, which stands for Rados block device, appears from the client's perspective as a block device that can be formatted and mounted locally. However, it cannot be mounted on multiple nodes at the same time, because you would need additional clustering to do that. Object storage can imitate the standard S3 protocol invented by AWS. On the storage nodes themselves, you can protect your data against data loss using either replication or erasure coding. Replication maintains multiple data copies over multiple nodes. And erasure coding is, roughly speaking, an equivalent of RAID distributed over multiple physical nodes. Of course, for this system to work properly, it needs to be backed by very fast networking. In our design, the network currently goes up to 400 gigabits per second, which satisfies the needs of modern supercomputing. If you want to know more about our networking concepts, please refer to our recently published networking white paper. And now, let's move to the demo itself. This is Tachyum Linux running in emulation virtual machine. Let's make sure it's really Tachyum Linux. We'll take some random executable binary. And there we go. The ls command is compiled for Tachyum platform. Now, the Ceph client is already configured here. Here's the Ceph config file. With this, we can query the server status. And now, nothing prevents us from mounting the Ceph file system itself. It's empty now. Only a default volume directory is present. Let's fill it with something. Now we have switched to a different virtual machine with another Tachyum Linux. Let's mount the Ceph file system also here. And there we go, the file is visible. How about NFS? Ceph has its own NFS server. I've already looked at the NFS mount location on the server side, and this is the command. It's also empty. We'll change it now. Yes, that's the mount. Let's look at the mounts from yet another Tachyum client. Now I've started a third virtual machine. Let's wait until it boots. And now I'm gonna mount the same NFS export as previously. Here it is, the magic of shared file systems. To show you that NFS server is really part of Ceph cluster, I've returned back to the first client, which still has mounted the Ceph file system. Let's look under the volumes directory. To our surprise, the NFS mount contents can be accessed also using Ceph file system, if you have enough access rights. So far, we've seen Ceph file system and NFS, the shared file systems. How about some block device? Let's create a block storage pool on the Ceph cluster. And on this pool, we will create a block device. It's here. Now, we need to map the disk to this client so we can access it. Done. Let's format and mount it. Nice clean block volume. We will do the same exercise as with shared file systems. But this time, we must unmount the device before we can access it from another client. We are back on the client number 2. Let's repeat the block device mapping. So this is Ceph. Before we finish this demo, let's explore some resiliency. This Ceph cluster is installed using a tool named Juju. We will log into the controller and do some chaos there, okay? You can see 3 nodes here with IP addresses you've seen previously in the Ceph config on the client. Let's shut down a random storage node without warning the cluster. The cluster should be able to survive such outage. There we go. The node number 1 is down. We're back on the client number 2 and we will try to access our data. This works. This also works. Well, everything seems okay. And that's all for now. Thank you for watching our Tachyum Ceph demo. Have a nice day.